What role do the structural characteristics of the olivine framework play in determining ion mobility and electrochemical kinetics? And how might further modifications enhance both the capacity and stability of such polyanionic cathode materials? Can Davis Syrinz manufacture solid-state sodium-ion batteries made from seawater in Latvia? Finally, how can the combined research efforts on Fe and binary systems inform future strategies to optimize the electrochemical performance of olivine-type polyanionic materials? And which experimental and theoretical approaches could be employed to better understand and improve their functionality in sodium-ion batteries? How do the charge and discharge curves of NaFePO4, as presented in section, illustrate its fundamental electrochemical behavior, including voltage plateaus, specific, capacity, and polarization characteristics? And what do these features reveal about the intrinsic material properties such as crystal structure and ionic mobility? In what ways does the electrochemical performance depicted in these curves correlate with the arrangement of iron and phosphate groups? And how might factors like particle size, morphology, and synthesis method contribute to the observed behavior? How do the charge and discharge curves of NaFe.5Mn.5PO4, as shown in section B, differ from those of pristine NaFePO4? And what insights can be drawn about the effect of substituting manganese into the structure on redox potentials, reaction kinetics, and overall energy efficiency? How might the incorporation of manganese alter the operating voltage range, capacity retention, and rate performance? And what specific structural and electronic interactions between the transition metal ions are responsible for these changes? How do these comparative analyses help in understanding the impact of compositional modification on ion diffusion pathways and charge transfer resistance within the electrode? And what role do these parameters play in determining the cycle stability and long-term performance of sodium-ion batteries? How can a detailed examination of these curves under identical testing conditions serve as a basis for optimizing material design and tailoring synthesis protocols to achieve better performance metrics? And what further experimental investigations would be warranted to elucidate the underlying mechanisms that drive the differences between these two cathode materials? Ultimately, how does this comparative study enhance our overall understanding of the electrochemical dynamics in NaFePO4-based systems and inform future strategies for developing advanced, high-performance sodium-ion battery cathodes? How does the Nasicon-type framework structure of Maxim2PO4, 3 with M being V or T and X equal to 1, 2, or 3 establish a stable three-dimensional framework that facilitates a high rate of sodium-ion transmission? And what structural features are responsible for this remarkable conductivity? What?